Still solving radical equations. Here are some that have two roots in them, so how do we handle this? Well, here's what you must not do. If you have all the radicals on one side of the equals, and then you square this, you'll end up having to square this entire left-hand side, which means foiling it, which means roots multiplied by other roots, nothing canceling out. It'll be quite bad. Very, very bad. So the way they've given us this one is the way you want them, with a root isolated on either side of the equals. Because from here, if you square both sides, this square cancels this root, you just get x plus 3. This square cancels this root, you just get the 3x minus 5. Nice. And now, if we take everything over to the right-hand side, we get 3x minus x is 2x. We get negative 5 minus 3 is negative 8 equals 0. So 2x is 8, so x should be 4. Does that actually work? Plug back into the original expression and you get root 4 plus 3 equals root 3 times 4 minus 5, which becomes root 7 equals 12 minus 5, root 7. So yes, no problem with that. There's one solution and it's valid. Here's another one where it's again set up correctly. We have roots isolated, one on each side. So if you square both sides, you get x minus 3 equals 3x minus 5. Load everything over to the right-hand side. 3x minus x is 2x. Negative 5 plus 3 makes negative 2 equals 0. 2x equals 2. X must be 1. So plug that into your two sides and you get root 1 minus 3 equals root 3 times 1. If you've noticed something wrong here, I see it too. I'll get to it in a moment. All right, you plug in 1 for both values of x, and so this gives you root negative 2 equals root 3 times 1 is 3 minus 5 is negative 2. Is that okay? The numbers match, which seems good, but the trouble is the square root of negative 2 for the moment is undefined. You can't do the square root of a number less than 0, at least not for a couple more years. So this one is invalid. The only place that these curves had a chance to cross was at x equals 1, but they don't work there. They're undefined, and so this solution must be thrown out. We only had one solution. It turned out to be extraneous, and so this thing overall has no solution.